Lesson 6. Sketch the graph of y equals the absolute value of x minus 1 plus 3. How does this graph compare to the graph of y equals the absolute value of x? Write a piecewise function for this graph. So here's the thing. The slope, there's no number in front of x, so I know the slope of the lines is just going to be 1 and negative 1. Positive and negative case. I can look at that and tell you that the vertex is going to be 1, 3. So literally I can go to the point 1, 3 and then just do a slope of 1, up 1 over 1, up 1 over 1, and there is the absolute value. That's what we want to be able to do. We want to be able to sketch that graph quickly. Now, that's it. So how does it compare to the graph of y equals the absolute value of x? Y equals the absolute value of x has been shifted 1 unit right, 3 units up. So it's like a 1 unit right, 3 units up shift. Okay, so let's write a piecewise function. So y equals the negative case if x minus 1 is less than 0. Notice I took the stuff inside. That's what, like, this is like my domain. I have a split domain. Then I have a positive case if x minus 1 is greater than or equal to 0. Now, we want to clean these up so that we get y equals. So we want to simplify this. So if I take this guy and simplify it, that just becomes x plus 2, that's a plus 2, I'm going to solve my domain, x greater than 1, greater or equal to 1. Now, I'm going to simplify that. So negative x plus 1 plus 3 becomes negative x plus 4 if x is less than 1. So get a load of this. What's the y-intercept of that? 4. It's right there. What would the y-intercept of that be? 2 if it kept going, but it doesn't keep going. So, are we good? So that's it. So hopefully I checked your homework while you were doing that. Okay, so now we're going to graph an inequality in 2 variables. So what does a single solution to this inequality look like? So give me just an answer. So if I just said, give me an answer to this problem. Well, you could tell me the point 1, 0. 3 times 1 plus 2 times 0, whoops, I need to be greater than 5, so like 1, 8. Plus 2 times 8 is greater than 5, so it's 3 plus 16 is greater than 5, so 19 is greater than 5, true. So that point works. So what does all the solutions look like? Well, it's referred to what we call a half plane, which is kind of weird to have half of something that goes forever, because a plane is supposed to go forever. So, how do you actually, do it? So, if you ignore the inequality and just look at 3x plus 2y equals 5, that is a line. If you solve for y, so that's negative 3x, 2y equals negative 3x plus 5, divide by 2, divide by 2, divide by 2, y equals negative 3 halves x plus 5 halves. So that gives me my slope and my y-intercept. So what does solutions to the inequality look like? Well, it's going to have to require some shading, just like on a number line, right? So this is the border. That's the border. So if I graph the y-intercept of 5 halves, so that's 2.5, so that's 1, 2 and a half. And I do a slope of negative 3 halves, so if I go down 3, 1, 2, 3, and over 2, 1, 2, I would get this line. But now here's the thing. That's equality. Well, this is not equal. This is strictly greater than. So that means I have to have a broken line, because I'm not allowed to have the equal. Equal would be the line. Now, what I have to decide is, do I shade this side or this side? I'm going to shade one of the two sides. So, Here's how you decide. Pick a point. Pick the easiest point you can. 0, 0. That's the point I'm going to test. 0, 0. So if I put in 0, 3 times 0 plus 2 times 0 is greater than 5. 0 is greater than 5. That's false. That says don't shade that side. So now if I pick a point on the other side, pick a nice one, like up here, something real easy, that is 0, 4. So if I plug in 0, 4, so that's 3 times 0 plus 2 times 4 is greater than 5. So that's 0 plus 8 is greater than 5. That's true. So that means you shade this side. Oh, you know what? I have a shader thingy bobber here. Let's see if we can do purple shading. Purple shading. Here we go. Purple shading. Oh, that's so cool. Look at that. So we're shading all of this. That is my shading. So that's what you want to do. So take a moment and think about what we did. And in your own words, explain how to solve a linear inequality in your own words. Okay, so basically, 1, graph the line. And decide if the line is broken, that would be less than or greater than, or solid. That would be greater than or equal to, and less than or equal to. Number 2, pick a point on one side of the line and determine if it is, if it is true or false. If it's true, you shade that side. If it's false, you shade the other side. That's it. Okay. So, we're going to create an inequality for this graph. So, I need the equation of that line. I need that equation. So, I need the equation of a line. So, to do that, I need slope and a point. So we got to try to find a point whose coordinates that we know for sure. So it looks to me like that right there, that point, that's what we're going to go with. 1, -1 is definitely a point. This right here looks like another point, which is 0, -4. Happens to be the y-intercept. That was kind of nice. So I need the slope. Well, I can do the slope from the graph. That means I go up 3, 1, 2, 3, and over 1. So it looks to me like my slope is 3. So my equation, get a little what I'm going to do, is y minus y minus -4 equals 3 times x minus 0. So y plus 4 equals 3x. So y equals 3x minus 4. So that's the equation of the line. Now, what I have to decide is, do I want y less than or equal to 3x minus 4, or do I want y greater than or equal to 3x minus 4? So I want one of those two, because the shading is an inequality. So that shading is an inequality. The equal part is the border. If that had been a broken line, then I would be doing less than and greater than. Okay, so how can I decide? Well, look at here. According to the shading, 0, 0 is supposed to be true. So if I put in 0, 0, one of those is supposed to be true. So which one is true? 0 is less than or equal to -4. Not this week. Or next. This is true. This is false. So that means I want that inequality. Now, some people go, oh, Mr. White, can I just look at the inequality to determine whether it's like above or below the line? Well, it kind of just, I can make it not come out that way. So you want to just, like, always, like, I'm telling you right now, the best thing in the world is to test a point. Okay. So you thought that was fun. So now let's take a look at solving an inequality with an absolute value. Mr. White, doesn't get any better than this. Okay, so, ready? Let's just pretend we're graphing y equals the absolute value of x plus 3. Absolute value. So I know that the vertex of this guy is negative 3, 0 because of what we did. I know the slopes of the lines are 1 and negative 1. So I know that, like, if I come over here to 3 and then just go up 1 over 1, up 1 over 1, there is the absolute value. There it is right there. That is y equals the absolute value of x plus 3. Now, I want to graph the inequality. I want to graph this. Well, what's this? Well, this is going to require shading. So the first thing we want to do before we shade is notice the inequality is strictly less than. That means that we do not want the lines, so we're going to break them. We're just going to put little broken lines because it's strictly less than, not equal to. But now I have to determine whether I'm going to shade. Okay, now this graph is broken into two regions. This is inside, and then all this is outside the absolute value. See that? So if I just pick a point like 0, 0, and I'm going to test it. 0 is less than the absolute value of 0 plus 3. 0 is less than the absolute value of 3. 0 is less than 3. That's true. Well, that implies to me that I want every point outside the absolute value. I want all of these points. Now, we're going to just kind of like take a moment and see if we can't like make sure we prove this. So if I found a point inside, like a nice point inside the absolute value, like negative 3, 4. Okay, so if I plug that number in, it's supposed to come out to be false. 0, 0 came out to be true. They both can't be true. So if I take the absolute, the original inequality, and I plug in negative 3, 4, 4 is less than the absolute value of negative 3 plus 3, 4 is less than the absolute value of 0, 4 is less than 0. That's false. That shows I have the proper shading. Sweet. Okay, let's see what's next. That's it, our last assignment. All right, make sure you do this because, well, actually it's not your last assignment because there's a review assignment. Make sure you do this because we're going to have a test in the near future. When? Not sure yet.